Hello friends, today we are going to discuss the determination of structure of simple molecule with the help of VSEPR theory. Now in last lecture we have discussed the different stereochemical rules of the VSEPR theory. Now let me summarize one by one. The first rule is that if the central atom is surrounded by bond pairs and no lone pair, then the geometry of molecule will be regular. Rule number 2, if the central atom is surrounded by both, that is lone pair as well as bond pair, then the geometry of molecule no longer remain regular. Rule number 3, if the electronegativity of bonded atom go on decreasing, then the bond angle go on increasing. Rule number 4, the repulsions of electron pairs involved in the multiple bonds are always higher than those involved in the single bond. However, the geometry of molecule is not so affected by presence of the multiple bond. Next rule, the repulsions between the electron pairs in the field shell is always higher than those in the incompletely filled shell. Now these are the rules. Now in determination of the molecule, structure of molecule, we have to consider these rules. That means here in the determination of the structure, first of all we have to decide the central atom. Then we have to determine the number of electron pairs around the central atom. Now here, depending on the number of electron pairs present around the central atom, one can determine the type of parent geometry. Now whether it is distorted or not, it is totally dependent on whether the central atom is surrounded by bond pairs or bond pairs and lone pairs. Now let us see the structure of the molecule. Now the first question here is how to determine the number of electron pairs around the central atom. Now dear friends, there are two methods. We will see one by one. First method here is determine the total number of valence electron in central atom. Then determine the number of electron contributed for bonding by bonded atom. Next step is to sum up these, that is total number of electrons contributed. By atoms. That will be equal to the valence electron of central atom plus number of electron contributed by bonded. Here determine the total number of valence electron in the central atom. Then determine the number of electron contributed for bonding by bonded atom. Then take the sum of the two, you will get the total number of electron contributed by atom in molecule. Now, fourth step is, suppose this total number of electron contributed by the atoms in a molecule is X, then fourth step is total number of electron pairs around central atom will be equal to X upon 2. Now once you know the total number of electron pairs around the central atom, now next job is to determine the number of bond pairs and the number of lone pairs. So next step, that is step number 5, determine the number of bond pairs. Now for this purpose, the number of bonded atoms will be equal to the number of bond pairs. Why? Because if the bonded atom form a single bond, then the number of bonded atom will be equal to the number of bond pairs. How? Let us consider the example of AB3 molecule. Now here in AB3 molecule, there are 3 B atoms which are bonded to central A. So obviously there are 3 bond pairs. Is it clear? So with the help of the number of bonded atoms, you can determine the number of bond pairs. Next step, determine the number of lone pairs. How we can determine the number of lone pairs? Now we know the total number of electron pairs around the central atom, that is x by 2. Now we have the x by 2 number of electron pairs, that means total number of electron pairs x by 2. So here we have to subtract the number of bond pairs. That means here number of lone pairs we can calculate. Now what we have done, we have determined the total number of electron pairs, and out of which we have determined the number of bond pairs, and these number of bond pairs now being subtracted from the total number of electron pairs around the central atom. Now we have two solutions. Number one, we know the number of bond pairs, we know the number of lone pairs. Now next step is to use the stereochemical rules. How? We will see later. The last step is to use the stereochemical rule for the structure of molecule. Now this is one of the method that we use to determine the number of bond pairs and number of lone pairs. Now dear friends, we have another method with the help of which one can determine the total number of bond pairs. Now it's a very easy method. Let's see how. Second method is a very easy method, because here in this method just I have discussed that we should know the how many electrons are contributed for the bonding by bonded atoms. Now in this step you see that what we have to do, we have to determine total number of valence electron in a molecule contributed by all atoms. For example, let us consider a molecule that is PCl5. Okay. Now, phosphorus, you know that it is present in a nitrogen family. Phosphorus. You know the value, how we can determine the valence electron. Now there are again two methods. Either you use the electronic configuration and count the number of electrons in the outermost shell, or you can go to the periodic table, and in the periodic table the group number of that particular position of that particular atom indicates the number of valence electron. Now the nitrogen, here the phosphorus present, you know, in the long form periodic table, that is it is fifth A group. No, the nitrogen family is present in a fifth A group. Now you know that here third A boron, fourth A carbon, and then fifth A nitrogen here. Now you see here fifth A means here the total number of valence electron or the contributed by phosphorus will be 5. Similarly, chlorine, here you know that the chlorine is present in 7th A group, that is halogen family. Now here see that all these atoms in that family will contribute 7 electron. That means here 7 electron. Now how? Now, so here phosphorus will contribute 5 electrons, plus there are 5 chlorine atoms, so 5 into each chlorine atom contribute 7 electrons. So total number of valence electron contributed in a molecule will be 5 plus 35. You got my point? So here what you have to do, 40. Now the next step is to do some arithmetic operation. Now how? If this total number of valence electron is 40, it is more than 8. If this number is 8 or less than 8, then we have to divide it by 2. But if this number, that is total number of valence electron, is more than 8, then it is to be divided by 8. So let us divide this 40 by 8. Now you see that the quotient is 5. This indicates that here the phosphorus atom is surrounded by 5 electron pairs. So the phosphorus, that is P, is surrounded by 5 electron pairs. water, H2O molecule, a simple water molecule, H2O. Now, let us calculate total number of valence electron in molecule. So, oxygen, again go to periodic table or write electronic configuration and count the electrons in the outermost shell. I use the periodic table. Now, this oxygen is present in 6th group. Of the long form periodic table. So, here the total number of valence electron contributed by oxygen will be 6. So, let me write 6 plus hydrogen, it is present in first group. So, it contribute 1 electron, or the number of valence electron in the hydrogen will be 1. So, there are 2 hydrogens, 1. So, it becomes 8. Now, dear friends, here this total number of valence electron pair is 8. It is 8, or if this number is 8 or less than 8, then we have to divide it by 2. So, let us do the step, that is these 8, divide this 8 by 2. You will get 4. Now, the total number of electron pairs surrounded by oxygen in water molecule will be 4. Let us take again next example. Now let us consider a very interesting example of ClF3. So as usual, we can have the total number of valence electrons in molecule. That is 7 for chlorine plus 3 into 7 for fluorine, because all these halogen atoms are present in 7th group. Now, total is 28. Since this number is greater than 8, it is to be divided by 8. Divided by 8. 8 is a 24. Now the 4 is 4, there is a reminder 4. You have to continue the division till you get either 0 reminder or 1 reminder. Mind it well. So here in this case, the 4 is greater than 2. So the second division, we have to divide it by 2. 2 2s are 4. Now what to do? You have to add first quotient and second quotient. That is equal to 5. Now you see. In case of ClF3, the central chlorine is surrounded by 5 electron pairs. Then the next step is to determine the number of bond pairs and the number of lone pair, as we have discussed in earlier examples. Do you got my point?